Hello, everybody. So today let's talk about streaming SSR, right? Everything, everywhere, all at once. So first, let me present myself. My name is Henrique Inonhe. I'm a software developer at CodeMiner42. Here you can also see my beacons in this QR code. So we have links for slides, social media, blog posts, all that stuff. So let's start, shall we? First, okay. Uh, Before we actually talk about streaming SSR, I just want to do a very brief recap of what SSR is, right? I think it's important. So let's say that this is your app right here. This picture represents your app. So we have a very beautiful web app that you built using React, right? And if you're not using SSR at all, if like back in the day when we only used to send just an empty HTML file and do all the rendering on the client alone. Oh, sorry. Yeah. We had to actually wait for the client to bootstrap and do all that stuff. So when we did not have SSR, this is the process that we had to bootstrap the application, right? So we send the HTML on the client. Once the HTML reaches the client, it initiates downloading the bundle, which is where like the JS and React code lives. And then once the code is downloaded, parsed, executed, then your app is rendered and ready to be used. Now, the problem with that approach is that when we do that, at first, when only the HTML is rendered, is sent to the client, this is what your user sees. Like before the client renders, this is what your user sees, just a blank screen, right? And this is not very good, mainly for two reasons. The first one is because, well, it's a jarring experience, right? Your user has nothing to see, especially if he's in a slow connection or maybe using a low power device that's going to take some time to load the JS and execute and do all that stuff. During all that time, all he's going to see is a blank page. And also, not only your users is going to have trouble seeing the page, but also the SEO engines, right? Nowadays, they do actually wait for JS to run, but I'm pretty sure that your SEO does take a hit. So to solve this issue, we introduced SSR, which stands for server-side rendering. Now, with SSR, the process is a little bit different, a little bit more complex. We have some more steps. So when we bootstrap an SSR application, we first have to fetch data on the server to fill in the gaps that we're going to have the page. We then do a pre-rendering of that page on the server. We generate some actual HTML that's actually going to resemble how your real application looks like. We send that HTML to the client, then we send the bundle to the client, and then we hydrate the app. Now, this hydration process is basically because we not need to actually render the client from scratch on the client, the application. But now we already have the HTML, we already have the DOM nodes. We just need to do some stuff like attaching event handlers and some other stuff. And we call this process hydration, right? So now, before the client hydrates, this is what your users see. And as you can see, we have this very same structures we had before. I just colored them gray because now just to hint that your application is not interactive yet, but at least the user and SEO engines have something to look at. And then after the client hydrates, your everything becomes interactive. Now, okay, so this is SSR very briefly. So before React 18, this SSR process, it happened in a single pass, or sequentially, which gives rise to a bunch of waterfalls. So like this is what a process looks like in terms of timeline. We have to do the data fetching for the whole application, and only after we do that is that we can start pre-rendering the application of the server, and then we have to pre-render the whole application, And only after that we can start sending the pre-rendered HTML. We have to send the HTML for the whole application before we can start sending the bundle, because the client's only going to ask for the bundle once it has the HTML that has the script tag that asks for the bundle. And then we have to download the bundle for almost the entire client. Like sometimes we may have some code splitting, but at least for everything that has been pre-rendered, like if something has been pre-rendered, that something absolutely has to be on the initial bundle. If there's something that's going to be lazy loaded, that cannot be pre-rendered. It doesn't work, and we're going to see why. So we have to send the bundle for everything that has been pre-rendered. And only after we do that is that we can start hydrating. And then once again, we have to hydrate the whole application before anything becomes interactive. Now notice that I've been emphasizing this whole application part, because this is what's going to be the biggest difference between SSR pre-React 18 and SSR streaming, right? So now actually these slides are not very important. What I actually want to show you guys is a demo, which I hope you're going to find very interesting. So, okay, let me first start the code here. Now, we have this application. I'm going to open the dev tools here, which I'm going to be showing sometimes. And now I want to show you that we actually like how this sequential process works. But before we do that, just let me explain what we're seeing here in the screen. Well, first, a disclaimer: I do not intend to explain like the inner workings of the demo, because it's kind of complex, uses a lot of like hacks and advanced features to accomplish what we're gonna do here. But an important part here is the following. Here at the left side, we're going to be loading a sample application, an example application, right? And to do that, we're going to have to pass through each of the steps we saw before. So we have like data fetching here. We have pre-rendering on the server. We have sending this HTML from the server to the client. We have sending the initial bundle, and then we have hydration. Now notice that this section here, this right sidebar, right? It acts as a remote control. What do I mean by that? Is that we can actually control when each of these steps are going to finish. This is important because this is what's going to allow us to see what happens in each of these steps. Like usually, all these steps, they happen like automatically. But the trick here is that we're going to be able to manually control when each of these steps finish. Also, you're probably wondering what these numbers here are, and it's because we're gonna have like six different components on the screen, and each of these components needs to fetch some data, right? They have some data that they need in order to be rendered. They need to be rendered on the server. They need to be hydrated. The only things that are not component specific are, in this case, the sending the HTML, because we do that in a single pass, especially because pre-React 18 would not use streaming. It's like we send everything at once. And the bundle, which is also a single bundle. But these other steps like data fetching, rendering, and hydration, they are specific to each component, right? Okay, so let's go. Let's see what happens when we first do the first when we hit the page, right? So let me explain some things. First, because this like to achieve this remote control here, like to be able to manually control when each of these steps are going to happen, we're using an iframe here. This is why we see two documents, but the one we're actually interested about is this app here. Like this is the document that represents the actual application that's going to be rendered on this left side. And notice that it is pending. It did not finish yet. Well, why? Because to send the HTML here, first we have, let's go back to the slides. I think it's going to help us. before we actually send the HTML, we have to do the data fetching, we have to pre-render, and only after that is that we can send the HTML. So like, let me just run you through these steps very quickly so you can see what we're actually going to see on the screen. And then I'm going to go back. I'm just finishing data fetching for each of these things, then rendering on server, and then send the HTML. Like, this is what we're going to see, right? And after we do all of that, see that this document is actually, the loading is actually complete for this request. Here we have the HTML that we actually see on the screen here, like 6 divs. Okay, now let's go back. I just wanted to show you what we're expecting to see here. But now let's go back and look a little bit at the code. Like, I did not expect you guys to fully understand what we're seeing here. I just want to show you like the code for you guys to have a rough idea to what expect, you know? So these are the components, the blocks we see in screen, and they represent different parts of the application. Right here, as it's just a demo for like educational purposes, we're not like, they're just blocks, but I want you to think of these blocks as, oh, this could probably be added like the header, this could be the comment section of your application, this could be the sidebar, this could be the footer, whatever, you know? Use your imagination. Also, like, let me show you what this looks like from the server's perspective. So this is the part, like the endpoint that sends the HTML for the app. Like, I don't want you guys to pay too much attention here because there's a bunch of magic using like web workers and worker threads to accomplish this demo. But the important part is, like, before we can actually render the application, which happens here. This is server rendering. We're using this render to string, which is a function we use to do server-side rendering on React pre-18. And the thing is, notice that in order for us to render the app, we have to pass the data. And where does this data come from? It comes from this data fetching. Now, I know that most of you guys have probably never seen this before, and it's okay, but it's the same thing that we do with Next or Remix, you know? So like in Next, this part right here would be the get server-side props or the get static props. In the Remix, this would be your data loader, right? Of course, it is much more ergonomic to do that in Next.js or in Remix or whatever, but it is the very same process, right? So like, let's say, let's use Next.js as an example because I think it's more usual, more common for people to use that. So in Next.js, you can only start rendering your application once your get server-side props has run, right? You cannot rendering before that because your application, your app, it actually uses the data that you return from get server-side props. So here is the same picture. And I want to show you the console because we're going to be able to see these things happening, right? So the logs in yellow are related to the compiler. Please just ignore those. The ones we're interested at are the ones prefixed with the blue server tag. So at first, when we request the application, let's look at what happens here. See, like each block has a data requirement, which are represented here by this fetch data calls. And they all start in parallel, right? This is pretty much what we want to do. So this part is nice. It already happens in parallel because we're using promise.all here. So they all start fetching in parallel. But notice that we're not rendering anything yet. And then once we start manually finishing these data fetchings, like see what happens. These get logged here. So like we know that these data fetchings have finished. And they can also happen out of order because they run in parallel. So they not necessarily need to happen in order, in the order they were made. So as you can see here, like we finished data fetching for the block 1, 2, and then 4, 3, then 6, 5. So it's not necessarily in order. So they start in parallel, they not need to finish in order. But notice that, and I have a log that tells us when we start rendering each of these blocks, we only start rendering the very first block after after all the data has been fetched, which is pretty much what happens in Next if you're not using the app router, right? If you're using the plain old Pages router, this is what happens. You have to run get static props or get server-side props before you actually start rendering anything. So this is what we see here, right? And then we can also control the rendering of each of these blocks in our demo here. So we can finish rendering the first block, and once we do that, the second block is going to start rendering. In this part right here, because well, it has to happen in order, right? I'm not really sure if there's a way to do that out of order using concurrent rendering. I think not, at least in the server, that's not possible. So this is always going to be the case. We're always going to have to render blocks in their order they appear, right? So we only start rendering the second block after the first, the third after the second, and so on. So let's do that. Let's render each of these blocks. So render the second, the third, the fourth, the fifth, the sixth, okay? So all these blocks got rendered, right, in order. And only after we rendered everything, the entire application, is that we can actually begin sending the HTML to the client. We cannot do that before we render everything, right? This is important right here. So like, this is why we have that waterfall we saw before. And now we're sending the HTML to the client. Like, notice that here, at the network tab in the dev tools, we didn't receive anything. Like, if you look at here at the waterfall, like when we start seeing streaming, we're gonna see that this picture is very different, because you actually can see the streaming coming in. But right now, as this does not use streaming, there's no data sent here at all. We didn't receive anything, any data yet. It's only when we actually send the HTML that this actually completes, and it completes like in a single pass, right? So far what we saw are these 3 steps here. See, we had to do the data fetching for the entire application before we could start pre-rendering anything. And then we had to pre-render everything before we could start sending any HTML, right? Now let's look at these other parts. Now, what I want you guys to pay attention to is, actually, let me refresh this. Okay, now I wanted to pay close attention to the requests we have here. So we have like the main application, which is this right side here, which is hosting the host stuff, this host.js, which is the bundle for this. So you can just ignore this. We have the actual application, which is waiting for the data fetching, the rendering on server, and also sending this HTML. But that's all. But remember that we also need, like, in order for application to actually become interactive and hydrate and all that stuff, we actually have to request the bundle, the JS code, right, for the client. And notice that this code right here hasn't been requested yet. We only have this now analytics, which is due to probably some extension that I use. The same thing for this CSS, so you can just ignore these. I'm sorry, I should have disabled these extensions, but I forgot about them. But these are not important. So let's do the same thing. We're going to finish data fetching for each component. We're going to finish rendering each component on the server. Then we're going to send the HTML. Now notice that it's only after that we send the HTML that it requests the bundle. So this is why like things happen sequentially even after server rendering, which is what we saw on the slide. See, like, we only start sending the bundle after we send the whole HTML, right? And it cannot start hydrating before it receives the bundle. So now let's manually finish sending the bundle. See, we just sent the bundle. Now this whole thing is hydrating, but it's still not interactive. We cannot, like, do anything with this yet. And because pre-React 18, we did not have concurrent rendering, we had to hydrate everything before anything becomes interactive. Now see, this is what our application would look like if it were interactive before. We have these blocks with ready written on them, and they have this effect when we click on them. And this effect is not achieved with CSS. This is important. This is like this flicker, this like blinking that these components do. They happen on JS code. So like they're only gonna this effect is only gonna be available once the entire process is done, once the component has hydrated. And notice that we had to hydrate everything before we could actually interact with anything, right? So going back, we have to fetch data for everything, render everything, and so on and so forth before we can actually start any of these steps. And this is this is precisely what Streaming SSR changes. Now, first, I'm gonna switch the branch here to the implementation. So like this first implementation, it uses plain old SSR. Now we're gonna move to the newer version, the newer implementation in React 18, which uses Streaming SSR, right? Okay, so there's a lot of things to unpack here, so let's go step by step. First, notice that we have much more controls over here, and I'm going to explain why this is the case. But let's go through a few concepts. So the first thing that Streaming SSR allows us to do is to actually break your application in parts that can be that can fetch data, pre-render the server, send the bundle, and hydrate all independently. So like remember that before in the older implementation, we actually had to do each of the steps needed to actually do SSR for the application as a whole, right? But now we can actually do those independently and in parallel for each part of the application. And to do that, we just need to wrap each of these parts with suspense. So like suspense is very powerful in this regard. It allows us to break the application in kind of like independent parts, as we're going to see very soon. But you're probably going to be thinking, okay, so like, why didn't we just do that before? Like, let me show you how it were before. Old SSR. Right, see here that there's no suspense wrapping these components. Like these are pretty much the very same components for the two versions. But here in the old SSR implementation, they are not wrapped with suspense. And here they are. So like you're probably thinking, whoa, why can't we just wrap them with suspense? And for those of you who have already tried doing this, you know that pre-React 18 SSR does not support suspense. So if you try, like when React 18 hits a suspense boundary during SSR, it's going to throw an error and tell you that it does not it does not support suspense. So like this is one of the big differences between SSR and Streaming SSR. Like differently from the old SSR, Streaming SSR does support suspense. Okay. Also, there's an important concept here that when we're using, okay, so like we can use suspense to break your application in kind of like independent parts, but there's like a first part that needs to be sent before we can start doing anything. And this first part, which is like the shell, like, and it's actually called like that. It's the shell of the application. So this shell is like the very first thing we're gonna load. Usually in a real application, the shell is like everything that's above the fold. Like not necessarily, but usually this is how you use it. And this first part, this shell, it still works pretty much like old SSR. So we have to like fetch data for the entire shell. We have to pre-render the entire shell on the server and send the entire shell to the client before we can see anything. But the thing is, and this is very important, like the shell, it does not include these components that are wrapped with suspense, right? It's everything before we reach the suspense. This is what it's called the shell. It's just the outer layer. And because of that, as you might imagine, it's much cheaper. It's much lighter to actually do the data fetching for the shell, render, and also send the HTML for the shell in the client. So in our demo here, let's run it again. the shell is actually just there's not, it's just the blank screen, but now something very interesting happens. So let's do this. Let's finish data fetching for the shell. So like let me go back so we can actually see what's going on. So we start fetching the data for the shell, right? We finish fetching data for the shell, then start rendering the shell on the server. We finish rendering the shell on the server, right? Now there's one interesting thing that happened already. Remember that we had to do things sequentially. Now here, because we finish rendering the shell on the server and we start hitting these components rapid suspense, we are already fetching data for them, of course, in parallel. That's why like we saw all of these at once. But we could do that before we stream any HTML. And now we can also start streaming HTML before we even finish this data fetching, or before because we did not finish the data fetching here, we just started. So we can send this first HTML before we do anything else. See? And now, like, this is our application. Notice that we still do not have the HTML for each of these blocks. This is only the shell. And what happens is, because we do not have the HTML for these components, what is sent is the fallback, right? Which is the spinner here, and which is like represented by these dashed boxes with the loading inside, right? So now, like, yet again, I wanted to emphasize that we start fetching data before we start streaming HTML, and we streamed HTML before we finish fetching these data. And we can see that here as well. See that now, like, we have some content sent, which is represented by this green. We did not finish this yet, but we can also see that we are sending some data, right? Okay. Now, once we do that, a bunch of things happen. First, notice that the bundle was already requested. So we did not need to wait for the entire application to be rendered to ask for the initial bundle, because the script tag that requests the initial bundle is actually contained in the shell. This is very smart, so like, see that now there are a bunch of things that there, like, a lot of things happening in parallel. They did not need to wait for each other anymore. Now, okay, so once we finish the shell data fetching, we finish the rendering of the shell on the server. We stream the first HTML, which corresponds to the shell. Then we have just something to look at, and notice that because we did not have to wait for the data fetching for the entire application, we did not have to wait for the entire application to pre-render in the server, and you do not need to send the HTML for the entire application. This is going to pop on the screen much sooner than on the other example, right? And now we can actually do data fetching for each of these components. So like, if I finish data fetching for this first component, we can see that it fetches the data, finishes data fetching, and starts rendering, right? So now here, just as before, like, data fetching can happen in any order, see? But the rendering itself still has to happen in order. Now, notice that as I finish rendering these components, the HTML pops on the screen here. Why? Like, because differently from what we saw before, that this request right here was not using streaming, was just like done in a single pass. This connection is still open here. Even though we streamed some stuff, this connection is still open, and it's still like streaming stuff. The server is still like keeping this connection alive. So as soon as the requirements to render each of these blocks are fulfilled, the server can then start streaming them to the client. So as soon as we finish the data fetching for this component and finish rendering the server, it gets streamed, even though the other parts of the application might still be loading data or might still be rendering the server, right? So we can do, and we can also do these, like, let me refresh. Sometimes the demo kind of breaks because as I'm using a bunch of hacks and I'm leaving the connections open for a very long time, I might have to restart the application. Just a minor nuisance. Okay, so let's do this again. So we finished shell data fetching. We finished rendering the shell on the server. We send the HTML for the shell. Then let's say, now I wanted to notice that this did not need to happen in order. Like the only thing that needs to happen in order is like once a component starts rendering in the server, we have to finish it because it blocks the other parts. But like I could, for instance, let's say that the data fetching for the fourth component finishes first. I could start rendering this component first in the server, and it's going to appear first. Like even though these components they like kind of are before this one on the React tree, like let me show you, right? This fourth component is after the first, the second, the third. If this component finishes first, it does not need to wait for the other components to finish fetching data and finish rendering on the server. You can just pop on the screen, right? So like notice that all these things, they're actually happening in parallel. Just it's like rendering, not exactly, but the data fetching and like the fact, like I think concurrently is a better term here, right? They're happening concurrently. So we can render them out of order. See? Pretty cool, right? Okay, so now we have the HTML for the whole application, but of course, before it can actually become interactive, it needs to hydrate. So in order to hydrate, we need to do like three things. First, we need to send the initial bundle because it's the initial bundle that contains the React code. And it's also the initial bundle that is going to trigger the lazy loading for each of these components bundles. Then we have to receive these components bundles, and then we need to hydrate. Now, let me show you what this looks like in a very linear fashion, right? So notice that we're still waiting for initial bundle. So we send the initial bundle here. Now, once we do that, we after it loads this initial bundle, it requests all the lazy loaded bundles for these components here. And they also happen all in parallel, right? And then we can send these bundles, and notice that once we receive these bundles, the application starts hydrating. And then we can finish hydration for these components, and they become ready to interact. Okay. Now I want to show you some things. First, I wanted you guys to notice that. Okay, so let's go back. Let's finish shell data fetching. Finish the shell for rendering on the server. Stream the initial HTML. Now notice that like in the first example, like in the first occasion we saw, we actually stream the HTML, like we finish data fetching for each component and we finish rendering the server before we send the bundle. But these things, they did not happen sequentially, they happen in parallel, you know? Like the only reason they're happening sequentially here is because you're manually controlling each of these steps. But like while these things are happening on the server, while we're fetching data for these components on the server, while these components are rendering on the server, the client is already downloading the bundle, which is very different from what we saw before. Like before on the old SSR, the bundle could only be requested after the data fetching for all the components and the pre-render for all the components had happened, and the HTML for all the components had streamed, you know? Now this is different. So because this is the case, we can actually finish sending the initial bundle even before we actually fetch data for any of these components, even before we rendered any of these components on the server. It's all happening in parallel. And also notice that we can even start requesting the bundles for these components before we finish any of these things on the server. It's all happening in parallel. We can also finish sending the bundles for these components before we finish the data fetching, before we have any of these HTMLs. So like when we do that and we actually start streaming these components, they immediately start hydrating. They do not need to wait for the bundle. So like before we had to wait for data fetching and the render in the server to actually ask for the bundle and receive the bundle. Now we can actually have the bundle sent to the client before we even start, before we even finish data fetching and finish rendering in the server. So by the time the HTML for this component reaches the client, we can start hydrating right away. Okay. And moving on to the next interesting part is that because everything, like all of these components are independent, we can actually hydrate them separately. Now, this blows my mind because before, remember that because everything was sequential, the whole application became interactive at once. And now, like, notice that these components here, they did not even finish data fetching on the server, but now one of them is already fully interactive. See? So like, let's do an experiment here. We could have a situation where, for instance, the first component did not even finish data fetching on the server. The second did, so we have the HTML. And the third, not only it finished rendering on the server, but also is already hydrating and finished hydration. See? So like we can have all these components in different states, in different stages of this SSR process. They all like can do these things independently. Now let me run because my time's running short. But there's one more very cool thing I want to show you, which you probably have heard or not. I know, like of a feature called selective hydration. So React, because it's using concurrent rendering in this streaming SSR, it does not block the main thread. So we can actually interact with some stuff while this stuff is rendering. And this is nice because React actually prioritizes hydrating the things that the user has interacted first. So let me do you a quick demo here. So let's first load the shell, which we need. We load the initial bundle, right? Let's load the bundle for everything. No, actually, this is not going to work. Sorry. Let's do this again. Let's finish the shell. Let's initial bundle. Let's say that we, I don't know, like finish the data fetching for both of these components and rendering on the server. So we have the HTML ready. And now let's send the bundle for both of them. But now, like the bundle of the third component is going to be sent first, and of the fourth component is going to be second. And the reason why this component doesn't turn to hydrating right away is because this is a dumb mutation and like it's a little bit hackish. So don't worry about that. But now I'm going to click on this component. See, I'm interacting with this component. And I'm going to finish the hydration of the third before and the fourth after. But notice that like it prioritized hydrating this component. Let's see this again. I think it's going to be clearer. So we send the HTML for both of these. We send the bundle, right? So they start hydrating. Oh, wait, I think demo broke again. Yes. Too much time with connection open. Things like that happen, right? Okay, send initial bundle. Okay, send the bundle, interactive this guy right here. Now, I can actually, oh no, this didn't work. Sorry. I get confused sometimes. It's too much stuff. Okay, now let me interact with these guys first. I'm gonna send the bundle for this guy. And now, just as I send the bundle here and I finish hydration, well, they're all gonna be ready, but notice that this gets ready a little bit first. So like this is what selective hydration does. It's pretty interesting. And it allows us to prioritize what we're gonna be hydrating. So notice that now with streaming SSR, all of these things, they happen in parallel, they happen independently. So then we can come back to like what we saw before and actually the title of this talk, which is like before with old SSR, we had to do things like sequentially. So we had to do data fetching, we had to do rendering the server, we had to send the HTML, we had to send the bundle and hydrate all in sequence. Each of these steps had to wait before the other could initiate. And also notice that there's also a sequence in which part of the in what place we are, right? So like we first do all the work on the server, then we do this like in between work here. And then only after that, we do all the work on the client. But now with streaming SSR, we actually do everything. So we do data fetching, we do rendering on the server, we send bundles, we do hydration, we do everything. We do those things everywhere. So we do this work on the server and on the client and all at once because they all happen in parallel independently. So this is why. So there we have it. With streaming SSR, we actually can do everything, everywhere, and all at once. So this is the repository that has this demo I just showed you, so you can play around, try to figure out how it works, or even if you are feeling adventurous, you can improve it. And that was all I had for today. So thank you all, and just a bagel to reference the title. Oh, by the way, one other thing I forgot to include here, but just to recap, you can find me in these links. Feel free to reach me, and thank you all. Goodbye.